Were you wondering what this little piece was that came in your kit? Well, you're finally in the right place to figure out just what it is and how we're going to test your bridges. Let's get right into it.
The first step is we want to get some numbers. Let's weigh our bridge and jot that number down, which should be a pretty small number. And let's also position whatever we decide to test our bridge on 7 inches away, like we talked about earlier, and get our bridge nice and centered. Here's our testing mechanism, which we are going to be attaching to our bridge and loading down with weight. Remember to save a space for it when designing your bridge, but if it doesn't necessarily fit anywhere, you can always screw the top off and screw it right back on once you slide it in. While filming, we actually noticed we didn't do a very good job supporting our testing mechanism. We went back and added another member that spans the top and helps support it. There's also no harm in testing your bridge from the bottom. If that makes sense for your project, go ahead and slide it in there and give it a try. But we are going to test this one from the top. Go ahead and get it nice and tight and slide it through, getting the bridge ready to hold some weight. Grab the handle of your bucket and attach it to the bottom of the hook. And check out how the whole testing setup should sit. Ideally with the bucket only a few inches off the ground, so when it does fall, it doesn't do too much damage. What are you going to weigh your bridge down with? Is it textbooks, rocks? Whatever you choose and whatever fits in the bucket, try to get some numbers down of what things weigh before, so as you add them to the bucket, you can keep a running tally of how much weight your bridge is holding. Go ahead and start loading your bridge, ideally when nothing's swinging around or moving, and also with some time in between the items that you add to the bucket, so you know exactly at what point your bridge failed. These slow motion shots are always cool to look at, and we encourage you to film the testing of your bridges if you have a camera available. Did you catch how this bridge failed? It was by twisting. Visit the last video and see what tips we give you to prevent your bridge from failing by twisting.
Here's what's cool about civil engineering, friends. It's not just about how much weight your bridge can hold, but how efficiently it can hold that weight. For example, it would be a piece of cake for a civil engineer to find the strongest material in the world and build their bridge out of a bunch of that material. But can you pause this video and think about why they don't do that, and why instead engineers rely on these efficient truss structures to build their bridges? If you said anything along the lines of, it would be too expensive, or unrealistically heavy, or maybe construction would take too long, you're exactly right. And that's where the principle of structural efficiency comes in, which tells us how much more times weight your bridge held than it weighed itself. And that's actually what we're going to be calculating in this project. Check out a quick example calculation here.
This bridge only weighed 0.013 pounds. Remember, balsa wood is light, but it held 13.6 pounds, which gave us a structural efficiency of 1,046, which is a crazy number if you think about it.
So now you should be all set. Feel free to decorate your bridges or have some fun with them. But remember, a big takeaway from structural efficiency, and a good rule of thumb in engineering in general, is don't add anything that adds weight and doesn't serve a real purpose. Anyways, have fun with your project and please let us know if any questions pop up. Thanks everyone.